Let's continue to take a look at this question 5 of Math Kangaroo Level 3 to 4, 2023. Okay, a light engineer in the theater turns the light on and off. So she uses the plan as shown. So you see the green, orange, and blue. So how long in total are exactly two, okay, exactly two of the lights are on at the same time? So for here, everyone, the most important thing for us to is to read this question carefully and understand what this question is really asking about. So it's asking, I'm only wanna exactly two of the lights on at the same time. Does that include, for example, I have three of the lights on at the same time? Does that include that? No, of course not, right? Because I only want exactly two, okay? No more, no less. Okay, so understanding this, you just need to take a look at this. First, we interpret this graph. The graph horizontally shows like as the time elapsed from 1 minute, 2 minutes, 3 minutes, and also the horizontally it shows different lights like on during which period of the time, right? So for example, during the first 1 minute, only the blue light is on. And during the 1 minute to 2 minutes, both blue and green are actually on. So this period is exactly what we're looking for, right? So what about 2 to 3? At this time, all of the three lights are actually on. So that's not the period of time we're looking for. And now path to 3 to 4 and 4 to 5, and both green and orange are on, and 5 to 6, both the orange and blue are on, and 6 to 7, you see, both green and blue are on, until 7 and 8, all of the three lights are on, so that's not the minutes we're looking for. So it's from 3 to 7. And now from 8 to 9, also you have a green and orange one. And from 9 to 10, there's only orange. And from 10 to 12, both blue and orange are on. So those are actually the period of time we're looking for. Here we have 1 minute. Here we have 4 minutes. And here we have 1 minute. Here we have 2 minutes. So that's actually in total, how many minutes? That's in total 8 minutes, right? Okay, so option C is the correct answer. For this question, the tricky part is you have to understand what the question is really asking about. So, if some of you understand this, at least two lights are on, and you're probably gonna include the times where all three lights are on. And in that case, you'll probably get the wrong answer by suggesting it's 10 minutes. Okay, just be careful. And in Common Core, this one is the data interpretation and reasoning with the intervals. And mostly in public school, they would just test on some like about the times and how to convert the minutes to hours, something like that, or how to interpret each of the interval represent how long of the time. And for this one, it's a little bit different. And other than measuring the time, you also need to like adding some like a requirement and to confine this. Okay, under certain circumstance, then you can count the duration of the time. If not, you cannot count. Okay, so that's why for the math chem question, it's a little bit harder than the in-school parts. So it's always good to practice. Now let's move on to the sixth question. So A folds the transparent paper along the dashed line. So what can he see? Basically, you see the paper is actually transparent. And after he folds, you see it's the upper part to the lower part, right? It's upper to the lower. So what he will see is actually the all of the lines being like overlap with each other, right? So how he's gonna overlap? How it's gonna overlap for the upper part to like beyond the lower part? That's actually the symmetry that we learned, right? So how symmetry works. For example, if I have something like this, and I said I will gonna fold from this side to this side, and it's gonna be exactly symmetrical when you fold it to the other side. So it's gonna look like this. So you're gonna use the axis of symmetry and to draw exactly the same thing. So the dashed line is actually the axis of symmetry, right? Using the dashed line as the symmetry line, and you can just draw for this one, you draw exactly the other half, but in the lower part. And for this one, you also draw exactly, that's actually from the second points, the second row's point, and to the last row's point. Okay. So for the first one, you can basically see a number 4, right? And for this one, you also gonna use the axis of symmetry, and this one is the outermost. And when you put it under, it's also gonna be outermost, right? And this whole line, you just need to draw it. And for this thing is basically unit square and right under in the second and third row. So when you put it down, it's also in the second, third rows unit square like this. So while you guys can see, that's exactly 4, 0, and 6, right? So what you can see is our option E. So option E is the correct answer. How about this one? It's pretty straightforward. It's a symmetry and transformation. And in class and in school, they will just have you to draw like around this axis of symmetry. But usually they will just be right on the like the shape. But for this one, is actually you see sometimes there's a little bit like distance to the symmetry line. So in this case, you have to like think about it carefully, which you should have the same distance to the symmetry axis of symmetry. So for example, here to here, you have like 1 unit points. And so from here to here, you also have 1 unit points. So that's how we gonna make sure it's totally symmetrical. Okay, so that's how we solve the 6th question.